Okay, oral presentation number 8. This is Berkeley Heights, New Jersey, a Mission 6 flight experiment, grade 8.
The growth and development of mosquito larvae in space. Hopefully, as you all know, our mosquitoes got off to a bit of an explosive start. In October 2014, our experiment was set to launch on spacecraft Orb 3 in Virginia. Unfortunately, our brave souls from Group A went through a tragic death when the spaceship decided to blow up. It was actually pretty cool to see something explode less than 2 miles away from us, but we were all shocked that all of our hard work literally blew up in our faces in a matter of 9 seconds. However, when Group B found out that there was another opportunity to go to space, they eagerly accepted the challenge in front of them. In January 2015, our experiment successfully launched on SpaceX 5 in Florida. We ended up killing the mosquitoes anyways, but they still got to go see the stars. Our question for this experiment was, will microgravity prevent the Aedes albopictus mosquitoes from developing into pupae? Based on what we observed, we can conclude that it is possible for mosquitoes to survive until the larva stage. However, like all great scientists, we must continue to test our experiment over and over again to ensure we get accurate results. Who knows, this test could have been abnormal, but we wouldn't know for sure unless more experiments were completed. If we did perform more tests, we would be able to accurately and surely say if mosquitoes are able to survive in space.
In the space experiment, 3 eggs out of the 9 we sent up hatched. 1 large larva was found, but no pupae or adults were discovered. In the ground truth experiment, only 2 eggs out of the 9 eggs hatched, although no larvae, pupae, or adults were found. Basically, the experiment in space did better than the one on Earth. We believe that this larva survived because it found an air pocket amongst all the water floating in the tube. It also must have found a food source to sustain it for as long as it lived. Based on what we discovered, we cannot form any absolute conclusions. The picture on the slide is of the larva that came from space. You can't really tell from the picture, but it was actually pretty large. We assumed that it was nearing the pupa stage, and with enough more time and/or more air, it could have potentially matured into a pupa.
There were many factors that could have added to the strange results we got. The first could have been the amount of air the eggs received. We could have put too many eggs in an enclosed area with not enough air, which could have affected the number of eggs hatched. Another factor could have been the amount of food available. The food that we put in the tubes with the mosquitoes is not actually what the mosquitoes eat. The food produces bacteria, which is the main food source for the mosquitoes. If the food did not produce enough of the bacteria, the mosquitoes wouldn't have been able to feed and therefore not develop. The last factor we could think of was the amount of viable eggs that were involved in the experiment. Although we tested the eggs previous to the start of the experiments, some of them may not have been viable. Since we were not in the spacecraft to see the experiment take place, we cannot conclude that these things actually affected the mosquitoes.
When the spaceship was launched, the eggs were dry. Once clamp A was released, water activated the development of the Aedes albopictus eggs. The experiment continued 9 days, so that if everything went according to plan, the mosquitoes should have matured into pupae. Then, the astronauts released clamp B to fix and preserve the mosquitoes. After that, we compared the results from space to the ones we got from the ground truth experiment here on Earth. In the picture on our slide is of our group unpacking the mosquitoes when they came back from space. Unfortunately, our collaborator, Bianca Urbina, was not able to make that event.
For this experiment, we used a Type 3 FME tube, which allowed us 3 different sections to put materials in. Volume 1 included dry mosquito eggs and nutrients, which contained brewer's yeast and lab chow, or hamster food. Water and air was in Volume 2. Volume 3 had a fixative, which was 10% neutral buffered formalin, which has formaldehyde in it.
As you all know, our astronauts are on a diet of dehydrated food and don't enjoy the luxury of a fresh meal. Mosquitoes can serve as food for crayfish and tilapia. In turn, we can eat crayfish and tilapia. If the mosquitoes could have survived in space, then crayfish and tilapia could potentially survive also. During a journey to the stars in the future, astronauts might enjoy a break from dehydrated food and enjoy some fresh seafood. Besides, it's pretty cool. Mosquitoes in outer space seem super rad.
We would like to thank our following sponsors: Summit Medical Group, Lindy, KPMG, Johnson & Johnson, and the parent-teacher organizations from Governor Livingston, Columbia Middle School, Thomas P. Hughes Elementary School, Mountain Park School, William Woodruff, and Mary Kay McMillan.
We would also like to give a big thanks to the program coordinators, Jim Flacker and Susan Rimbetzi. Another special thanks goes to Professor of Biology, Todd Lipdahl of Clark University, for eggs, nutrients, and special guidance. Of course, we wouldn't have been here without our amazing teacher facilitator, Pamela Wolzinski.
This concludes our presentation. Thank you for listening. Are there any questions?
My name is Rashad and I'm from New York. Why would you choose the mosquito, and if you had another insect, would you change anything?
Well, we originally were going to use sea urchin eggs because they were like small and they would be able to fit easily into the test tube. But then it turned out that they wouldn't last very long outside of the mother. So we decided to look for different like organisms that had eggs that were small enough to fit into the tube. So we used the mosquitoes, and I don't think we would have changed the insect. Yeah.
Yeah.
Okay, I'm Favor Idika from Guilford County. And where did you get the inspiration for this experiment?
Well, we thought that since no one likes mosquitoes, we would send them to space to see if we can, like, put them all there. But also, we realized that crayfish and tilapia are a really good food source, and they have a lot of protein, so.
Okay, let's thank the Berkeley Heights, New Jersey team.